Hai and salam sejahtera. My name is Vielinna Jeoclyn, Anak Vieny with matrix number 72863, and today our group will present about our project for TME 2234 Operating System course, and the topic for our project is scheduling algorithm for Unimas Web. So the code already count up the turnaround time and waiting time. So basically, the code already linked to the txt file which contain our job list. Now, here, this is the average waiting time and the average turnaround time. So now, we are going to take a look on the calculation of the algorithm for FCFS. The average waiting time can be calculated by dividing the total waiting time by 30, and the answer is 26,026.5. For the average turnaround time, we can calculate it by dividing the total turnaround time divided by 30, and the answer is 27,857.8.
Hi, my name is Haziq Dzakiryin bin Yusri, and my metric number is 69836. So today, I will talk about the shortest job next scheduling program. So SJN is non-preemptive by default. If you can see the program, why job 1 is the first one is that because the shortest job next scheduling algorithm sort all of the process according to the arrival time. Why job 14 is executed after job 1 is because it selects the process which has the minimum arrival time and minimum burst time. As we can see here, burst time of job 14 is smaller than the burst time of job 2. That is 1,495 for job 14 and 1,778 for job 2. For the calculation part of SJN, shortest job next, the average waiting time is total waiting time divided by 30. That will be 24,794.7. For the average turnaround time, total turnaround time divided by 30 will be 26,626.1. And then we go to the shortest remaining time scheduling program. This output is sorted in orderly by arrival time, hence the burst time was not in order. The average waiting time for this algorithm is 24,629.7, and the average turnaround time is 26,471. The number of interrupts incurred is 117, the sum of interrupt from job 1 until 30. So this is the calculation for SRT, shortest remaining time. The average waiting time will be the total waiting time divided by 30 will be 24,639.7, and the average turnaround time will be 26,471 by average turnaround time will be total turnaround time divided by 30, and it will be 26,471.
Hello sir, my name is Venessa Thomas and my metric number is 71881. Today we talk about the round-robin algorithm and the bar graph. The first job that has completely executed all the processes is job 14 because it has the lowest burst time than the others. And then followed by job 18 and other jobs until job 23 with the longest burst time. The average of waiting time for this algorithm is 49,855.4, while the average turnaround time is 51,686.8. The total number of interrupts incurred is 5,477. Next, for the calculation of algorithm for round robin, to calculate the average waiting time, the total waiting time is divided by the total jobs, which is 30. So we have 1,495,663 divided by 30, we get 49,855.4. Same goes to the average turnaround time. The total turnaround time is divided by total jobs, which is 30, and we have 1,550,604 divided by 30, we get 51,686.8. So the next I will explain about the bar graph of the algorithm performance. As we can see, the round-robin algorithm has the highest average waiting time and average turnaround time, as well as the number of interrupts incurred. There are also a number of interrupts for the shortest remaining time, which barely can be seen here because it has the lowest interrupts. After that, the second highest is the first come first serve, followed by shortest job next, and the last one is shortest remaining time. There are no much difference between those three algorithms. And for the first come first serve and shortest job next, they do not have the interrupts in the process. So that's all for my part. Thank you.
Greetings, my name is Dellon Brunnie and my metric number is 69486, and for my part I will talk about the comparison between all four algorithms in terms of turnaround time of the job, waiting times of the job, and number of interrupts incurred. For FCFS, the turnaround time of the job is 27857.8. SGN, it has 26626.1, and SRT has 26471, and RR it has 51686.8. The waiting time for the jobs for FCFS, it has 26026.5, SJN has 24794.7, SRT has 24639.7, RR has 49855.4. For number of interrupts incurred, FCFS and SJN has no interrupt, while SRT has 117, RR has 5477. Next is the advantages and disadvantages of the four algorithms. For FCFS, the advantages is doesn't include complex logic, easy to implement, and it will have no starvation. For disadvantages, no preemption process and longer time for process execution. For SJN, the advantages is shortest process will be executed next. More processes will be executed in a shorter time. Disadvantages is longer process have more waiting time and cause starvation. SRT advantages are faster than SJN and with no overhead charges counted. And the disadvantage is it has more processing time. For RR, the advantages is all processes given the same priority and it has no starvation. And disadvantages largely depends on the length of the time quantum, and it will also can cause a decrease in CPU efficiency. And that's all from me. Thank you.
Hi, my name is Deutero Kisoi with matrix number 70000. So our recommendation on the most suitable algorithm for Unimas Web is shortest remaining time. This is because based on the job list that has been given to us, which is job list 2, shortest remaining time turns out gave us the shortest average waiting time and also the shortest average turnaround time among all four algorithms with 24639.7 and 26471 respectively. Shortest remaining time also has the lowest number of interrupts incurred among all four algorithms, which is 117. Shortest remaining time also is the fastest algorithm among all four algorithms with no overhead charges counted. So, in conclusion, shortest remaining time is the best and most suitable algorithm for Unimas Web. So, that's all from our group. Thank you.